morning, Professor Sinclair. How are you?
Good. Well, I think professors can call each other by their first name.
I agree. I was being facetiously formal.
No, it's great to finally have this meeting. Thank you for organizing it.
Yeah, likewise. I've followed your work for quite a long time now, and very excited that we're going to get a chance to chat. I thought I'd ask the question that I would ask if we were meeting in your office or mine, and none of this were happening, but then segue from there. So in terms of what you guys are up to, just briefly, what are you most excited about lately, so we don't have to dive right into the dark of COVID-19?
Well, I'm most excited right now about how scientists are finally putting their ego aside and no longer only trying to prove that they're much smarter than each other. They're actually banding together and helping. The students are coming together on communities, on Slack, for example, and Zoom, and guys like me, people like us are getting together to focus our efforts to try and help with this one pandemic. I've never experienced in my whole life scientists coming together like this. And so that's the most optimistic thing that's come out of this. And my hope is that when we come out the other side next year, going back to normal life, that scientists as well as politicians and the general public understand how important it is that science is a part of society.
Yeah, no, I completely agree. I mean, I think, well, first of all, I think yours is a particularly competitive field where I don't know what the structure is in that field, but it's a particularly competitive field. And so it's nice to hear that people are banding together. I really feel they are. In the corner of neuroscience that I'm in, and in neuroscience generally, I mean, it's been quite vicious, right, as well. And at times, the communities band together, but it's for short periods of time. And I agree. I think that this is going to create a lasting tide change. And what's really exciting to me is I'm in touch with a number of kids who are in their teens. And, we think a lot about how they're stuck at home and they're, some of them, we believe are going to dissolve into a puddle of tears or something, but nothing could be further from the truth. One thing that I'm thinking about a lot these days is the fact that, they're in this heightened peak of neuroplasticity that, your colleagues, the late, David Huberman and Torrance and Wiesel, discovered these periods of plasticity. And we know that periods of plasticity are supported by, unfortunately, periods of high alertness and even stress. But what they're learning about now is remarkable, right? They're learning about these things, that there are these things called viruses. People finally understand the difference between viruses and bacteria. They're understanding that, why antibiotics alone wouldn't deal with this. And they're learning about animal trafficking, international policy. Now they're learning about it through a fire hose of dirty and clean water, so to speak. But I think that we are going to spark, by we, I mean the scientific community, and this pandemic are going to spark a generation of kids that are really going to feel a call to arms. At least that's my hope. And I think doing things like this and the fact that scientists, and hopefully scientists and politicians, are going to band together, I hopefully will galvanize we'll hopefully live for a very long time. But as we do, we need to bring people in. So that's my hope in this time.
Right, and that's one of the reasons for doing these kind of podcast and video chats, because people are getting a view of what it's like to be a scientist. And, we're trained as scientists to stay in our ivory tower. A few of us stick our necks out at great risk to our reputations. But I think more and more it's being seen as important that we scientists, especially doctors who are, on the front lines and seeing how this particular pandemic is going, that they're stepping in front of cameras and in the radio and podcasts and educating the public. It's never been so important to be up to date with information. And if you think back about 10 years, maybe even less, people, even kids, would have to get their information from, dodgy websites, and even going further back, like when we were kids, from newspapers, printed newspapers, where the reporter talks to people like us, maybe gets a quote, maybe if you're lucky, it's not out of context, puts it in a headline that, you're always upset with. And that used to be how scientists were represented. And no wonder most scientists said, I'm done with this. I'm not talking to reporters again. But now that we can do exactly this kind of thing, it's a totally new world. And I think kids and even, adults as well are seeing probably for the first time that scientists are actual real people and they say reasonable things.
Yeah, no, you make some excellent points, and we should. I will, give you a nod there because you've been an early pioneer in doing this. Like you said, I don't think people understand the internal risks of being getting information out there and being a scientist that's seen and heard. I can say it's. I think there's also a positive tide change there, and we have actually today and on this, not to bring any additional anxiety to, but we have some folks from National Institutes of Health who follow you, right, and follow my account, and who are very happy about the fact that scientists are doing this, some of the cell press leadership. And so it's really wonderful. This pandemic, as horrible as it is, I think is making people realize that most of the papers will never be seen or understood. And as you mentioned, when press releases come out, most of the time they're butchered. I mean, we're grateful that the various high profile venues will cover our work from time to time. But so in terms of what's actually going on with COVID-19, one of the things that I'd love your thoughts on is, Stanford and some of the institutions around Boston are excited about these tests. They're going to look at IgM, which of course is going to show up early and kind of an early detection marker, as well as IgG as a, for the listeners, antibody-based sort of late detection marker. So IgM meaning if you see that, it's probably early in somebody has COVID-19, but it's early in the course of it, IgG later. But you know more about this sort of thing than I do. We, of course, work with antibodies in my lab, but as a neuroscientist, we don't think about it the same depth. Let's say I were to take a test and I have no IgM, so I get a confirmed negative IgM and I get a positive IgG, versus let's say I get a IgM and IgG positive test. What to you would that? How would you interpret something like that?
Well, the same way that anybody would. I don't think it's up for a lot of reinterpretation, but just to explain to those who are not familiar with these tests. So the main ones that you would get at a doctor's office, I don't believe they're able to be provided without a doctor's permission. What you get, it's a strip. Actually, I have a demo one here. I wasn't planning on showing it, but I may as well. Mm-hmm. So a friend of mine sent me one as a demo, and I'll show you what they look like. So they come in a little package like this, okay? And you can see here SARS-CoV-2, IgM, IgG, okay? And you rip this open. I'll rip this one open. I don't think it's going to harm it. Put it back in the bag. And they look, now I've never taken a pregnancy test, but I have seen one. It's pretty similar, right? You've got, here you put the blood. The instructions recommend using a venous blood. You can use serum or plasma or whole blood. I've also seen other kits using a drop of blood, just a 20 microliter drop of blood in there. And then there's a buffer that has some detergent and other things in there. And it runs up here. And you probably can't see this well, but there are actually 3 gradations. They're actually across the top. And the one at the furthest end is the positive control. If that one C doesn't light up, then the test has failed. And then you've got your IG, I forget which is which, but I think it's IgM on this end and IgG, but you'd have to check. They all come with instructions. But to answer your question, what's going on here is that the antibodies IgM, IgG are floating up this little strip, and you've got the recombinant protein. In this kit, they don't say, but I'm assuming it's the spike protein on the outside of the virus that's there, and then you get a red color.
Yeah, I would hope so, because that would speak to the specificity, right?
Yeah. Now they're not perfect, by the way. I will get to the answer, but I want to give the background on this. These are only about 89 to 90% accurate. There are some new ones that claim 95% accuracy, and that's both positive and negative. You can have a false negative. So in other words, you may have had the disease or have it, and it's 10% chance you're going to show up as a negative. So these aren't definitive, but if they do show up positive, I think that's pretty good sign. And what I think these are good for is actually giving a very quick 15-minute answer, and then you can follow up with the other tests, such as a polymerase chain reaction, a PCR test, which is done more typically in hospitals. And there are other tests like DNA sequencing. So what does it mean? If you end up with both bands, what that represents is you've got an early and a late immune reaction. So IgM, as you mentioned, Andrew, will go up early. This is a graph of over time. And then you seroconvert to IgG, which gives you the longer lasting protection. So, we've all had, or hopefully all of us have had mumps vaccines and measles. So we're carrying IgGs in our bloodstream. So if we get exposed again, we'll have that. And it seems that most patients have a nice seroconversion after a few weeks, maybe a few more weeks beyond that, depending on how active your immune system is. If you only have IgG, the line, one of these lines with the positive control, what that I would say typically represents, the tests are never perfect, but what that indicates is that you've had the disease earlier. IgG will stick around for at least a month. We know that from studies in Asia and in Germany. But my guess, and this is a guess, it hasn't been proven, but it's similar to most viral infections, you'll probably have those IgGs around for at least a year. They probably provide good protection. It's not proven. There's still rumors that people are getting it twice. I'd be interested, Andrew, in what you think, but people getting it twice, to me, I think it's more likely the tests are failing rather than the human immune system.
Yeah, I agree. I would be very surprised if this business of people getting it twice turned out to be true, simply because of the first of all, how long my immunology colleagues tell me, just how protracted this is, the long onset, 5 to 14 days, the fact that IgM comes up quickly, and that IgG does seem to accumulate, they tell me, fairly robustly. And so these home kits, as you said about 85 to 90% accuracy. That's what
this kit says 89 to 90.
Yeah, that's good.
Sensitivity.
I mean, in terms, yeah. So I'm not seeing a lot about double infections, but and I know you've talked about this publicly before as well. But in terms of the mutation rate, which for the listeners, of course, would raise questions about, mutations can make the virus less good at doing what the virus wants to do, burn itself out, so to speak, or the mutations could cause other problems. The one I was concerned about early on was the virus developing some sort of mutation that would give it some way of accessing neurons in longer living cell types. Not unlike herpes virus that stays on neurons very long periods, entire lifespans. Is there any evidence that the mutations that are taking place would give it more of a tendency to infect neurons? And for the listeners, that the concern about neurons in particular is not just because I'm a neuroscientist, is that the neurons you're born with are generally, aside from small populations that you might gain, generally the neurons that you're born with are the ones you're going to have your entire life, whereas other cells are going to turn over. So if neurons were to be infected and the virus were stable there, that could be quite bad.
Yeah, for sure. Well, I don't know of evidence that they can even infect neurons in culture. Do you know, Andrew?
As far as I know, the virus cannot infect neurons, but the mutations that have shown up, I think, are being tracked, and I haven't. I'm not in a position to judge whether or not those mutations suggest that the virus is somehow mutating toward versions of itself that would better infect neurons. I would not.
I'd be surprised if that were possible, because it doesn't enter if you don't have the ACE2 or ACE2 enzyme on the outside. So, I mean, if there's no evidence of ACE2 on the outside of neurons, then I think we're okay. The spike protein, which engages with ACE2, it's pretty hard, I would imagine, to evolve the ability to find a new related target. Even still, we're only seeing one major change in the spike protein out of Wuhan. Now it's quite prevalent, though, in Europe and the US. There's this variant. But that's only one amino acid change. Typically, to jump between species, I don't know about cells, but to jump between species, you need 5 or so amino acid changes. And I would guess to jump to a new cell type, you might even need more of those to find a new target. Now, the worry would be is if something is very similar to ACE2, like ACE1, and that's found on neurons, then you could imagine that it could jump. But I think at this stage, we shouldn't worry listeners that it's a likely thing. It is mutating about as fast as flu, which does come back every year, of course. But I don't see any mutations that are alarming just yet.
Mm-hmm. That's reassuring to hear.
Andrew, the one thing to bring up is cats. It's now possible to infect large and small cats. We know that. So I raised the possibility that cats may continue to spread this particular strain of COVID-2 for a while. They don't practice social distancing. It's very hard to stop that. And so what I'm hoping is that cats do not act like a reservoir of coronavirus like birds do for the flu. It's just something to keep in mind that could be where we go. But I think 99% what's going to happen is that in 2 years this will all be behind us and we'll move on, but hopefully more prepared for the next one that's definitely coming.
Yeah, I agree. Yeah, I read the Science article about cats, and I think ferrets are now going to be the major experimental model. They have been for a long time for respiratory diseases. They're quite good model. In fact, my apologies to the ferret lovers out there, but that's the way it goes. In terms of cats, I was at a meeting in Istanbul last summer, and it was remarkable how many cats are roaming the city, but in huge numbers. And so this thing about cats is not trivial. It's not just about isolated suburban homes with a cat. You probably worry less, but in cities where cats are roaming quite extensively, it's really something.
And in Australia, there's millions of wild domestic cats, formerly domestic. Yeah.
Is that right? So I wanted to ask you, I know that you have a number of practices that you talked about before, cold water exposure, skipping meals, this kind of thing, but just generally to sort of head in that direction. But with the topic in mind of just stress generally, we're trying to run this knife edge. And I know that as we're having this conversation, there's a silent conversation between us too, which is, how to get the information out and yet, and have people sensitized to the fact that this is very serious. I think almost everybody hopefully believes that now, regardless of the causes, and to sidestep the conspiracy theories and say, look, this is really serious. There's a tremendous number of fatalities, and to, sort of focus on how serious this is, and then at the same time not to, push everybody into a state in which their immune system is depleted. So one of the things that I'm very interested in that my lab works on, and where I think there's real points of convergence between what you do and what I do is, I'm very interested in the stress response as this, primal response that wasn't necessarily designed to keep us safe from tigers necessarily, and the classic examples, but it was really designed for us to navigate situations exactly like this, right? 300 years ago, it might have been a drought or a famine or a disease for which there were no home kits or tests or CNN or Fox News for that matter, right? It was just the stress response was designed to mobilize us. And one of the collection of papers that I'm such a fan of course, is the beautiful work of Bruce McCune and others showing that stress can really deplete the immune system. But I think one thing that the listeners should probably know is that the stress response in the short term and secretion of things like cortisol and adrenaline were actually designed to buffer against things like we're experiencing now. And in fact, there's actually a transient boost in immunity in the production of leukocytes and things like that when you have transient increases in cortisol. What all this means is that if you're feeling stress periodically throughout the day, provided you're doing other things to mitigate your stress, you're probably giving your immune system what it needs, which is the ability to respond. And I think we've all experienced this when we work very hard, or we go through final exams, or you finally finish a grant or a big project, and then you finally rest, and then you get sick. And that's because the so-called sympathetic stress response actually mobilizes the immune system. And I feel like the press has missed this because we think stress is horrible, but stress is actually doing a number of positive things for us. And I'd love your thoughts, David.
Yeah, you're right. Our work is really similar in that way. So the term that we use, and you may use too, is hormesis, which is a little bit of adversity. If it doesn't kill you, it makes you stronger. And hormesis is a term that really talks about temporary stress. And by stress, it can be psychological or physical, but it cannot be chronic. In other words, it cannot be long-term. So for instance, in my world, we found mostly in mice, but in humans as well, that if you do certain things to your body that don't harm it permanently, such as high-intensity interval training, weightlifting, going hungry for half a day or even longer, as long as you're pulsing it, your body will go through a period of quote unquote thinking, oh my goodness, I might die next week, my food's running out, or I'm being chased, actually maybe by a tiger. But you need to allow the body to recover. You cannot have this chronic situation. I mean, if you work out every day, you don't build up as much muscle as if you let your body rest. Same as if you don't eat well. You do need periods where you need to grow tissue and supply the minerals, vitamins. And so it's all about this hormesis effect. And I think for psychology, for mental and neuronal states, it's the same. You've got to have some periods where you're heightened. But if it's chronic, we know that leads to what we call inflammaging, which is just a catch-all term for the horrible inflammatory state in tissues of the elderly.
Yeah, it's really interesting. I know a lot of people are into this intermittent fasting thing, and when my lab was in San Diego, I was down on the street from Sachin Panda, of course, has written extensively about this work. I mean, my protocol has been one that I learned from a neurosurgeon. He's now the neurosurgeon. He used to be in my lab. He was a kid then. Now the neurosurgeon at Neuralink, at Elon's company. And he has a rule where once he skips one meal a day, he just picks one. Maybe it's breakfast, maybe it's lunch. Most people tolerate skipping dinner. Maybe it harkens back to childhood when, in the old days, they threatened to send kids to bed without dinner, but a terrorishment really. But I think that your mention many times before of being hungry is for maybe short or even longer periods during the day, provides not too extensive, are really powerful. And I want to just underscore the message that you've given previously many times is, we have these reward systems in the brain, these dopamine systems, and they're vastly misunderstood. People think that dopamine is only achieved when you get the degree or the cash outcome or the mate or whatever it is. But actually dopamine is secreted en route to rewards. And the amazing thing is that when we can positively associate some pursuit and some sensation like hunger with this is good for me, it flips the sign of the neurochemical identity of that. What I mean by that's geek speak for when you know something is good for you and you do it and you're conscious of the fact that it's good for you, you actually start secreting chemicals that make it feel good over time. And this is pathology. This is actually fundamental to our evolution. And so now, for me, I actually associate the feeling of hunger as kind of a positive one. It also makes eating much more rewarding when you finally do eat, which is an entirely different thing about dopamine schedules and things, but we won't get into that now. So I think you've been a proponent of, I'm not here to just, to give thumbs up to that just because we're here. I would be saying this anyway. Attaching a positive notion to something like hunger that would otherwise feel aversive or bad can actually be very powerful.
Yeah, that's good to know. You're the expert, right? I found myself experiencing this. So anyone who tries intermittent fasting, either skipping a meal a day, which I at least do that. I haven't had any breakfast. I'm having a coffee, which is not a lot of calories. So there's that. But when you first try it, and if you want to try it, I highly recommend that you stick with it, because what you feel when you're first doing it is just, it's more, I find it's more of a habit that, oh, if I didn't eat, I'm not going to be able to think clearly, blah, blah, blah. But if you do it for a week, and certainly by the second week of not eating three square meals a day plus snacks, you really do end up feeling a lot better. B, you think, why was I eating all that food? Because and then it turns out it actually feels good, right? Getting to what you said, Andrew, which is that after that week or two, you actually feel way better and happier and clearer mentally, not always feeling satisfied.
Yeah, in this period of where obviously, and myself included, there's a heightened level of stress. I'm not used to reading the paper first thing in the morning and looking, and there's just a heightened level of vigilance. The other feature of these, peaks in stress, and again, the chronic stress is the issue. Maybe in a few minutes we talk about what sorts of things you do and I do, and what the literature says about ways to bring ourselves in 24 hours through sleep, but also one of the things that's very clear is when we're in these heightened states of alertness, whether or not it's because we're missing a meal or deliberately, or because of the just general situation that we're in, the brain actually is more plastic and available for change. I'm going to throw out some names here that some of you may recognize, but some of you may not. But David's, some of his colleagues there at Harvard Med won the Nobel Prize for showing that the brain can change a lot early in life and less so later in life. And they were right that the brain is very plastic up until about age 25, and then it gets harder to learn things. But subsequent work showed that the brain really can change and learn things, including forgetting bad things and dissociating the negative emotions with bad things, as probably the entire lifespan. And the key entry point to that is a heightened level of alertness. It's just we can't learn passively as adults. So I look at this period of COVID-19, heightened levels of alertness, skipping meals deliberately, as tools also to make brain plasticity more available to us. I mean, one thing's for certain, we're going to forget this period. It's our brains are in this mode of plasticity, I think, and the challenge. I mean, our brains were designed to be plastic periods like this because designed to prepare for the next one, right? And so I think we are getting better. And I'm just curious, David. So, like in your day-to-day routine, because I know everybody's life differs, but I imagine your lab is still working, albeit remotely. Mm-hmm. And what's your sort of cognitive state these days? You feel like you seem very calm, but in general, you seem like a very calm guy.
My wife wouldn't agree with you, but I'll tell you, and I will tell you this because I'm wondering if other people experience this too in their personality, and then people can give the thumbs up if they want. I find that if there's small amounts of stress, I don't perform that well. I ruminate, I pace, I don't sleep well. But when things hit the fan, then I get into this Zen-like state. I once almost crashed my father's little boat, and I can very clearly remember I walked up the front of the boat, jumped off the front, and got between it and a rock and saved the boat, while everyone else was basically screaming and running for their life and jumping overboard. So that's my personality, and this is one of those times where I just think now's not the time to panic. It's the time to focus and get us through this. And whether it's doing research or keeping your family together or keeping your parents from getting depressed if they're overseas, for example, that's all the stuff that we should be focused on.
Yeah, you make a really good point. So in our lab, we run animal studies, but we run these human studies where we put people into quite stressful scenarios in VR, and oftentimes we have electrodes in their amygdala as well, because we borrow them from neurosurgery. And what you find is that at low levels of stress, obviously stress is low, but as people have a lot of different things they need to sort through and navigate environments and cognitive tasks, it doesn't quite harness all of their mental faculties. And so it does make them a bit more stressed. And then when they hit situations where they have to funnel everything into a tight channel, we see a relaxation of the stress response. People are able to bring themselves into a kind of more relaxed plane, and everything's clear. And actually, I'll just share, I'm sure you know this, but for your listeners, when we're in a heightened state of activation, actually there's a change in our visual system so that we get very good at tracking individual things in the environment and everything else disappears. It's like portrait mode on your smartphone. You get a kind of blurry background, but one thing becomes in very sharp relief. And this is nature's adaptation for allowing us to track the threat or whatever it is that we need to tend to. And it's very interesting because we can actually control that periodically throughout the day. So for the listeners that are feeling rather discombobulated and overwhelmed, you can learn to focus on individual tasks better and better, and that actually has a calming effect. The other thing is that we're aware that the opposite is also true, that periodically throughout the day, it's very useful to try and see large environments, or kind of what we call panoramic vision, trying to not always be focused into a screen. We're violating that now, of course. But a lot of people now are talking about the huge number of times and all that. That's all terrific, and people need to stay connected. But trying to see out to a long distance, whether or not it's through a window or you are able to get out for a walk and see a horizon, this actually relaxes a brainstem circuit that, when we're in these tight focus modes of vision, really can lead to kind of the feeling of tightness and chronic stress. So periodically throughout the day, it's good to get away from screens, and if you can see a horizon, even better. But I think that people that are cooped up now are starting to feel this. And one of the reasons I put this out there as a tool is, A, it's backed by the literature. The circuitry of the visual system was designed for this. And the other is that, we have some weeks to go now. And I'm noticing that people are starting to hit that point where, we did it for a week, we did it for 2 weeks, 3 weeks, 4 weeks, but this is actually the time when I feel like we need to ratchet down and really be smart about this physical distancing. And that's going to mean we're going to need to incorporate more and more techniques to get through this. And I'm very conscious of that.
Right. Based on my colleagues and my own experience, it's getting harder and harder being cooped up, depending on who you cooped up with. I'm here with 3 teenage kids, so that's an interesting experience. But what I'm finding personally, and I'd be interested in what you think is going on here, is that I'm looking for positive rewards. So, normally I'm working during the day at work with colleagues, it's smiling, joking, there's a lot of social interaction. Without that social interaction, I'm turning to my phone and almost obsessively, like a parrot in a cage, pulling its feathers out, tapping on social media, looking at stuff, looking for new rewards. Do people, like what I just wrote, blah, blah, blah. And it really is an obsession. I've got to fight it and get out, and look out the window. And I think it's unhealthy. And if I'm suffering from it, there must be millions of people feeling like me.
Yeah, so a couple points. So I've heard a definition of addiction before that I quite like, because which is that any behavior, whether or not it's drinking water, heroin, or cell phone use, can be problematic or not. The question is whether or not a behavior is keeping the baseline of your life flat, improving the baseline, or sending it down. And you have to drink a lot of water before the baseline of your life starts to go down, although you can do that, right? Whereas with heroin, it happens fairly quickly. The phone is an interesting one because it's a double-edged sword. It really can enhance the richness of things, where you can have interactions like this, connect to family and so forth, and colleagues. But there's a point at which it really starts sending our productivity down, our well-being down. And I'm in touch with some of the major technology companies out here that devices like this. Part of the problem is staring into a small box, whether or not it's a laptop or a tablet or a phone each day, is bringing our eyes into this so-called vergence eye movement. It activates a brainstem circuit, which it's not stress, but it's the vigilance. It's like spending nickels all day or spending quarters all day. Pretty soon you're taxed. And so getting into these modes of panoramic vision, a couple of people have asked, you can do it indoors by, you keep your head and eyes stationary, and it's just sort of seeing yourself in the environment you're in, as opposed to focusing on something in your environment per se. So in other words, you dial out your vision so that you're tends to do a number of different things, but it really does relax this autonomic response that otherwise drives a little bit of stress. And so periodically throughout the day, what I'll do is I'm so undisciplined with the phone, David, I actually lock mine in a safe. And because I find myself collectively reaching for it, and I consider myself a pretty disciplined person, but it's that difficult. And just an hour or 45 minutes of being away from these devices, I feel like resets something. And I think what it's doing is it's allowing my vision to scan my environment. Now, of course, I'm a visual neuroscientist, so this is what I do, but we know that relaxes the circuit. There's never been a period in time when we've been in constant vergence eye movement like this. We used to walk between meetings and you would dial out your gaze, you'd take a walk outside, dial out your gaze. You get these recovery bouts. And right now we're pushing ourselves, and right now we need those reserves. So I'm periodically throughout the day, I'm putting the phone in there, and I realize there's an anxiety with being away from the phone too, but that's precisely the match to what we were talking about earlier with skipping meals. That low level, that's a different form of hormesis.
Yeah.
Right?
Someone just wrote, "I'm going to put my phone in the mailbox." I highly recommend against that.
I do not do that. That's right. But our vision, I think really drives our internal states to such a large degree that we forget. It's not just the content of what we're seeing, but how we're viewing the world around us. And we are also, with all these video chats, there's no optic flow. So normally when we see things and they're moving past us as we walk and move and shake hands of colleagues and things like that, there's optic flow. Looking at a focal point in 2 dimensions, there's a reason why when we bring subjects to the lab, we only require a 90-minute or 2 week. Their eyes fatigue, it's stressful. And so I think we need to be cognizant of how much effort we're putting on system, in particular with vision. Yeah. But in any event, so you and I might be the 2 scientists who are been most vocal about supplementation. And I don't want to make this a discussion about compounds necessarily, but I am curious, and since we can talk about what we do, right, safely, I'm interested in just in terms of NMN, right? You get a lot of questions about this. My downstairs colleague is Roger Kornberg. Mm-hmm. So for those of you who don't know, his father, Arthur, discovered RNA, and then his son discovered the structure of RNA, and they both won Nobel Prizes. So, real underachievers in that family. But, Roger, I've seen, has been, very visible about NMN and the fact that it takes in. So, there's an interesting kind of tide change there too, where scientists are getting a little more vocal about the things that they do. In situations like chronic stress, right? Is NMN, and I don't want to talk about metformin because that's a sort of a different discussion maybe, or we could hold off on that. But is it mimicking anything of the stress response at a cellular level that you could tie to sort of a short-term behavior? Does it sort of look like fasting biochemically? Does it look like an ice bath exposure biochemically? Or does it have a kind of a more chronic long-term effect? I'm just very curious about your ideas on this.
Yeah, just a quick bit on the biology to catch everyone up. So there are enzymes that we study in my lab called sirtuins, and there are 7 of them in the body. And everything from a yeast cell to, there are examples in mice of these genes promoting health, and even in some cases their longevity. And it turns out if you make an animal less sick, it lives longer. That's the nice side effect of being healthy. So we're not trying in my lab to keep anybody alive in an old state. We're actually trying to keep people younger. So that's the bottom line. These genes and enzymes, the enzymes in particular, they require NAD to work. Now, NAD is, we all probably learned in high school, is important for hundreds of enzymatic reactions in the cell. But what we discovered, my colleagues and I around the world discovered in, what was it, the late 1990s, early 2000s, that these enzymes also use NAD. And they sense the amount of NAD in the cell, whether it's in the nucleus or the mitochondria. And the amount of NAD tells the sirtuins how much to defend the cell. The loss of epigenetic information. I think Andrew will come back. So they defend against epigenetic information loss. They defend against DNA damage. They're anti-inflammatory. They suppress tumors. So they're very good. But as animals get older, and probably as people get older, the levels of NAD go down and the activity of these defense enzymes goes down. So we believe that one avenue to keep these enzymes at their youthful levels of activity is to keep the NAD levels high so that they function optimally. And we've done that quite a lot in mice, actually. I've got to keep an eye here to see if Andrew comes up. So what we've got is NAD boosting molecules. The one that I've said that I take is called NMN, stands for nicotinamide mononucleotide. How it works exactly and the clinical data and preclinical data in animals is described extensively in the book that I put out called Lifespan. But essentially what we find is in mice, we do see that NMN mimics hormesis. So you get mice that are old that are, once you give them NMN for about a month, they're more like younger mice and also mice that have been exercising or fasting. So they become thinner, they can run further on a treadmill, they have more energy. And so this is actually, you know, if you want to boil it down, although scientists are not really allowed to do that, but think of it this way, NMN is exercise in a pill and fasting in a pill, as far as we can tell. And if we look at NMN versus the gene expression patterns, so how the genes respond to these effects, they actually do very similar things. Now, it's not perfect, of course. No one molecule can mimic a healthy diet and exercise alone. And interestingly, if we combine exercise, healthy diet, and NMN, we get the best results in terms of endurance. All right, let's get Andrew back on here. Okay, we'll tell Andrew we've been talking behind his back. What a useless researcher he is, and Stanford is a second rate. Oh, we love Stanford. Stanford's even better than Harvard, I think. Sorry, did you hear that? I wasn't sure.
Yeah, I think I caught something about a Stanford Harvard. There's a long tradition of Stanford Harvard jokes. So, but I did catch everything you said. And so, yeah, so I'm very interested in this because, you know, for instance, I know what I do, and I do periodically take NMN, although not every day. That's just, but I do other things like the fasting and some cold exposure stuff. But I'm curious. Let's say I take, and we won't get into specific protocols, but let's say I take NMN while fasted. Is there a synergistic effect of NMN and fasting as opposed to taking NMN while, you know, on a kind of standard meal schedule? Would, in your opinion, I realize there's no clinical data on this yet. Right.
So, before I address that, I'll just get a few things off the table. I'm not an MD, so this is not medical advice. That's important to know. I saw somebody ask, what products do I take? I don't actually buy mine. Mine is from manufacturers, and I actually have some in my basement. So I don't actually know what products are good or bad. I do know that for any supplement, you want to look for good manufacturing practices, GMP grade, high quality, and trusted manufacturers. And another reason for not mentioning specific products is, if anyone has ever Googled my name, you can see that my science, my name, my picture is being ripped off to sell products. And if I say a name of something, it'll immediately appear and be used to sell products, and I can't have that. And certainly Harvard wouldn't be pleased either. So unfortunately, in the current climate, I can't mention specific products, but do look for quality material and stay up to date with the clinical trials. And then the last thing before we get back to what you asked me, Andrew, is I am doing or helping to do clinical trials with NAD boosters. We're entering phase 2. The company is called MetroBiotech, and in full disclosure, I'm the co-founder, so I do own some of the company. But the studies are done by independent people. It's been run out of a hospital locally here in Boston. I mention that because, first of all, please don't write to me asking to get in the trial. I have no way of doing that. And these are small groups of people. But I will tell the world as soon as I'm able to the results of those studies. I can tell everybody that there's been nothing negative, nothing showing up with the liver or blood pressure. So they do appear to be, at least that molecule that we're testing is in small studies, short-term studies, very safe. But you always need longer-term studies. You never know. Okay, so to your question, does NMN plus fasting work? I think it probably does, but that's based only on speculation. What I can tell you is that we put mice on an NMN diet with or without exercise. And the mice that were on either one of those, these are old mice, 20-month-old mice, either one did about the same. They run about 50% further. But the mice that were exercising and on NMN together did the best. So that there is some rationale that the combination of molecule plus lifestyle changes is additive.
Interesting. Interesting. I wanted to just touch briefly on sleep. I know we're getting close to the end of the hour and this will cut out and I'll probably get knocked off one more time and I'll try and get back on if I do. So sleep obviously is immensely powerful as a restorative for our immune system, for our mental faculties, everything. I mean, I think that's finally landed home with most people. And yet there are a couple things that I wanted to just touch on that we know from the circadian biologists and my colleague Samer Hattar and I had him on the other day and offered some really useful things that are practical tips that I think most people are probably not doing that could really make a big difference in terms of sleep quality. And these are non-supplement based, although I'm happy to talk about what I do for supplements for sleep if people want. Again, I'm not a physician. I always say I'm not a medical doctor, so I don't prescribe anything, but I'm a professor, so I profess lots of things. So that's actually my disclaimer at the beginning of every talk I give. And then it's just clear. But so one thing that we know from now 4 excellent papers is that morning sunlight around sunrise, although it doesn't have to be at sunrise, and evening sunlight, even if it's a very short day because you're at a northern latitude, seeing that light, and it has to be to the eyes. There's no extraocular photoreception, as the nerds say, which means you can't shine light in any orifice besides your eyes to get the light information to the rest of the cells of your body. Not your nose, not the roof of your mouth, not your ears, sorry. But when you get that light, in particular sunlight, although bright artificial light can do it too, you set the timing of your morning cortisol pulse and you set the timing of your evening natural melatonin pulse, not supplement based, but natural melatonin pulse from the pineal. So you're actually timing the onset of sleep and the quality of sleep by getting that morning light pulse. And it turns out that it's not blue light. Everyone thinks, oh, it's blue light that's so essential for these cells to be activated in the eye that signal the rest of the body. Turns out it's the contrast between yellow and blue. And it's this elegant nature mechanism because that's actually, as you watch the transition, watch a sunrise and watch a sunset, yellows are getting brighter and blues are getting darker. And so these melanopsin cells, as for the aficionados, the name doesn't matter, are integrating that information, and staying on a regular circadian schedule facilitates sleep. It makes sure that the cortisol spike is early in the day. My colleague in psychiatry, David Spiegel, says they use a late cortisol bump as a pretty telltale readout of anxiety and depression. And when they look at a treatment designed to push back on anxiety and depression, what they're really looking for is to try and get that cortisol bump earlier in the day, because again, that's a good thing, and melatonin late in the day. So viewing morning light as we're cooped up indoors, even if it's through a window, viewing evening light. And the evening light, it turns out, can buffer against a little bit of the nighttime light exposure. And the last thing I want to just say about that is that Samer tells me he has a paper out that was in Cell last year, and there's another one coming out of David Berson's lab at Brown in humans, showing, this will help with your cell phone thing, David, that bright light exposure between the hours of 10 p.m. and 4 a.m., really 11 p.m. to 4 a.m., but it starts around 10, triggering of this circuit in the brain involving a structure called the habenula. But it's two things. One, it kind of creates a pro-depression circuit. It buffers dopamine release, which is not good. But the other thing is it signals to the pancreas. There's a habenula to pancreas connection, and they think this is how blood sugar gets dysregulated. People become either hyperphagic or anorexic in various forms of depression. So there's this very interesting link between light, sleep, and circadian rhythms, and all of it really boils down to very simple cost-free practices of getting light in your eyes in the morning, getting light in your eyes in the evening, avoiding bright light exposure in the middle of the night. I just wanted to offer that as a discussion point, because I think that even though our work is somewhat distinct, there are these points of convergence where really we're trying to harness the natural biology. Your work on N and NAD, for me, I don't like the word hacks, because hacks implies that you're taking something that exists for one purpose and using it for another purpose. And, it's sort of like, well, anyway, I can't come up with a good example, but it's sort of like using my dog as a way to, you wouldn't put him under a tire to try and get a car out of a ditch, right? That's not what his purpose is. But what we're talking about are these neural sets that are designed, and these cellular pathways and molecular pathways like the sirtuins that were designed for this purpose. These are not, they are nature's design. So I just
there are a number of questions coming up about NMN and NAD. It turns out that NAD levels go up and down during the day. The NAD levels are controlled and controlling circadian rhythms, and a couple of science papers about a decade ago came out on that. And so I find anecdotally that taking my NMN when I'm traveling really does help with jet lag. And whether it's placebo or not, you can't tell with an N of 1, but it does fit with the biology that the whole circadian cycle over the 24 hours is intimately involved with NAD. Somebody asked what NAD is. So NAD stands for nicotinamide adenine dinucleotide, just a small chemical that carries hydrogens around. But it's essential for the circadian rhythm. If you disrupt NAD, you actually have disrupted sleep. So Andrew, you and I are actually holding the same elephant from different ends.
Fantastic. Yeah, and I noticed a couple of people have asked about supplements for sleep. I again, as with David, I'm not a physician, but I can talk about what I do. What I found very beneficial, and actually, I don't feel guilty about saying this because several folks who work at NIH have asked me for these protocols. They're struggling with sleep too, right? Just scientists have biologies as well. The two things that have been most helpful to me, and again, check with your doctor, are theanine, Theanine, which is a GABA precursor, GABA being a neurotransmitter that promotes calm, and magnesium threonate, which is THREONATE, both of which allow people, or I should say the easier transition to sleep. They make some people quite drowsy. You wouldn't want to take them during the daytime. And again, check with your doctor, but for me, these have made all the difference. People have asked about supplementing melatonin. Melatonin's major role in development is to suppress the onset of puberty. And I get a little bit freaked out when I hear about people supplementing melatonin, especially in kids. Melatonin is chronically high in puberty and then becomes, phasic as we age. And I just generally taking hormones without any kind of regulation and without working with a doctor closely, to me, kind of freaks me out. And so it's one of the reasons why I don't take melatonin. But I do control my melatonin by getting as many photons, as much light in my eyes, not obviously to the point where you blast the retina and destroy it, because, soon this may change thanks to David and other people's work. But so far, retinal damage, you don't want it if you don't have it. Let's put it that way. But using light to control the onset of melatonin is one thing. Taking melatonin is another. So I actually discourage people to do that.
Okay. Well, I've found L-theanine is fantastic. I take it most nights, actually. It's very helpful to me. It's a nice natural way to do that. Occasionally a little bit of melatonin if needed. I've been turned on to Dr. Parsley's drink. Do you know about this? It's
this is I think it's a magnesium cocktail, right?
It seems to work, so I'm onto that. But I agree with you. If you can do it naturally, it's so much better. I actually have the blue light glasses in the morning. Sometimes I use those in the middle of winter. There's a company called AYO that makes it.
So you're talking about glasses that deliver blue light, not buffer blue light. Okay.
I do
Yeah.
both.
So that will work if they're bright. So these melanopsin cells that set the clock, they will respond well to blue light. They like these yellow-blue contrasts best, but blue light will do the trick. It's kind of an interesting story. It's an in vitro, in vivo thing. Turns out when you pull these cells out in a dish from animals, obviously, and record from them, blue light makes them fire action potentials like crazy. These are the cells that set the circadian clocks, folks. And then, but when you look at their connectivity in the intact retina, they're getting inputs from what sort of standard rods and cones. And so they will respond to red light. They'll respond to yellow light. A lot of people think the blue blocker glasses, the ones that are designed to eliminate blue light from screens, they're really only taking care of a small fraction of the mechanism. And I'm yet to see a technology that capitalizes on these new results, these yellow-blue contrast. But I'm sure it will.
What about the program F.Lux that makes your screens turn yellow?
Yeah, that's going to help that. So the more amber hues, the color of light that is least good at triggering activation of these cells, and under conditions where you should be asleep or it's nighttime, you don't want activation of these cells. Amber light of the sort that F.Lux, the program F.Lux, or that I think Apple has incorporated into a number of their phones, that's going to buffer a large amount of the wavelengths of light that would stimulate these cells and throw your circadian clock and your habenula and potentially even your pancreas out of whack. But I think there are going to be some newer technologies to get at the yellow-blue as well.
Okay.
I have a feeling we're going to get kicked off here in a second.
Yeah, there have been a lot of good questions coming up. I'm going to try to address those later. I have a newsletter that people can sign up for on lifespanbook.com also. We've only touched on about 1% of topics that we could, so we should do this again, Andrew.
I'd be delighted to. Thank you so much. I've obviously, as I mentioned in the beginning, followed your work for a long time. A huge fan. I'm excited about your work on visual repair. I look forward to maybe a discussion about that in the future. Super exciting. And thanks to everybody for the questions and for tuning in. Far too much than we could cover in an hour. But David, thank you so much.
Thanks, Professor. Thanks, Andrew.
Thank you.
Yeah, take care, everyone. Be safe.